All right, the purpose of this video is going to be for our basic transformer connections, transformers level 1. And everybody hopefully has heard the terms delta and Y when it comes to transformers. Delta Y is pretty much just talking about the configuration of either the primary or the secondary. So if you hear that you have a delta Y transformer, which is probably the most prevalent transformer that we're going to hook up, that means that it is a delta primary and a Y secondary. Another one that we'll typically use is a delta delta. We don't really see a whole lot of Y primaries, and we don't really, mostly we don't see a lot of delta secondaries, but the primary one that we're going to be dealing with is a delta Y. Okay. So what are the characteristics? So what's the difference? Why do we have a delta and a Y? And so here, this is the bottom left and the bottom right hand side. First is the bottom left hand corner delta, and that is in the shape of delta for the Greek letter delta, which is essentially a triangle. And for our delta system, we can see that we have A phase going to B phase. So here's A phase. If we tie in our black wire here to A phase, and we have our red wire tying in here into B phase, and then we have our blue wire tying into C phase, which hopefully we all know is our three-phase colors. A phase goes through the winding into B phase through the winding to C phase, and C phase through the winding to A phase. That is our delta configuration. The other configuration we have over here on the right-hand side is our Y. Aptly named because it looks like a freaking Y. So we have our black wire that goes in and hits one winding. We have our B phase, our red wire goes in and hits one winding. And we have our C phase, blue wire goes in and hits one winding. And the cool thing, now I'm going to use green, even though obviously green is just a ground wire, grounding conductor. I'm going to use green just because the white neutral doesn't show up very well on the white screen. So you'll see that in a Y, those windings all hit a common point. Okay? A delta, A to B, B to C, C to A, and in a Y, A to a common point, B to a common point, C to a common point. So that's how they look in our configuration of A, B, and C. How do they look now on these diagrams that we have on the top? So if we look at this one on the top left, the first thing I want to talk about real quick is that you'll see that we've only got one winding. These are the windings, right, for our transformer. So these are our windings. And you can see that per phase, there is one winding per phase. So these are called single voltage units. Single voltage units. So I have a single voltage, so I'm either gonna have a single voltage delta, single voltage Y, or a single voltage delta delta, delta Y, Y delta, Y Y. So they're single voltage because there's only one winding per phase. So the first thing that I typically try to ask myself when I'm looking at these things is, do these three windings in the top left-hand corner, do these three windings hit a common point? And if you look at this, you can see right here is a common point. So we know at this point that this is a Y primary. Every time we do these, the primary is going to be on the top. So I have a Y primary because A phase, we can see A phase here goes to there, to the common point. B phase to the common point, and C phase to the common point. So that is a single voltage Y. Now on the bottom, do we see anything on the bottom that hits one common point? I think the answer to that was going to be no. So right here, I have this one going to A phase. And if we follow this line all the way down over here to the right, we'll see it hits here to this A phase. Let's draw that as an A. Now we'll go over here to B phase, the center line. I'll actually draw that in. Here's B phase, and B phase comes down here and hits those points. And then we'll go with the blue C phase. And there we see that we go from A through the winding to B, B through the winding to C, C through the winding to A. So I have a Y primary, delta secondary on that one. Okay. So we look at the one over here on the right-hand side, and we do the exact same questions to ourselves. Do we have a common point? If we start here with A, we see that this goes A here, and this A goes to here. Then we take this B wire, and that looks like we got a delta. And here's our C. I forgot to draw the B in there. So it looks like we have got a delta primary. And now let's look at our secondary. This goes down to here, goes down to here. Our red wire. Oh, I forgot to write A again. There's B. Here's A. And now last but not least, we got our C. All right, so it looks like we've got a delta delta. Okay, piece of cake, right? Single voltage units. So there's one more curveball we can kind of throw at you, and that's when we come up this way, where we have dual voltage units or multi-voltage units. Okay, because now I have more than one winding per phase. All right, so when we did DC theory, when we did AC theory, or just to stick with DC theory, when we had DC theory, we know that in series, my voltages are additive, and in parallel, my voltages are the same. So I can have, because they're dual voltage units, I can have either a high voltage or a low voltage option. High voltage is obviously if they're if the windings per phase are in series or if they're in parallel. So now I can have either a high voltage Y, a low voltage Y, a high voltage delta, or a low voltage delta. Again, pretty much depending on whether or not my windings per phase are in series or in parallel. So I'm still going to make the determination first on whether or not it's a delta or a Y. So in this case here, on the left-hand side, do they hit a common point on the primary? And the answer to that is yes. They hit a common point. So I know already that this is going to be a Y system. And now I got to look right here. And that right there shows me that those two windings are hooked up in series. So I know that that is a high voltage Y configuration. Because here is my A phase. And here is my B phase. And last but not least is my C phase. So A to neutral, B to neutral, C to neutral is a Y. Now I'm going to come down here. This one, especially when they cross them like this, it confuses a lot of people. But I can already tell you this is a low voltage because they are not tied together in series. We can see that, I hope. Now I guess the biggest question is whether it's a delta or a Y. But I can tell you this is going to be low voltage, but we'll investigate it further. So here's A phase. And so my A phase being my top wire. Actually, let me erase that. Here's A phase, the top wire. And we can see that that ties in right there. It also comes over here and hits this side of that coil. We follow this black line over, and it also hits here and this side of this coil. Okay, again, they're not in I can already tell that they're not hooked up in series like this is right here. So I already know that this is going to be low voltage. So that's A phase. Now let's track B phase. Here's B phase. And with my B phase, it comes up here, and it ties in over here, and it ties in right here, and it ties in right here, and it ties in right here. And now I'm going to switch over to C phase. And that is going to tie in there, 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 and there. So here I go on the going from left to right. I go from A to parallel B to parallel C to parallel A. That is a low voltage delta. Okay, so I have a high voltage Y, low voltage delta. Easy stuff. All right, so last but not least, the one on the right-hand side, bottom right-hand side, we can kind of do the same thing here. We can tell that this one's already going to be a low voltage and a high voltage on the secondary. Now, is it a delta, Y, what is it? So, for the most part, if we just want to look at this picture real quick, do we see any of these hitting a common point? No, we see that we go A to B, B to C, C to A. So that's going to be a low voltage delta. And then also, here's A to B to C. Yeah, so this is a high voltage delta. Okay. So now the math on these. There's not very much math on there. The only math that we really have is we have winding voltage and we have line voltage. And we have winding current and we have line current. So when we talk about winding voltage and line voltage, you guys have probably all heard the 120, 208 and 277, 480. Well, if you take out your trusty calculator, come on, calculator, there it is. And we take our 208 volts, divide it by 120 volts, we get a multiplier of 1.73. If we take our 480 volts and divide it by 277 volts, you will see we get the same multiplier of 1.73. So that is our relationship voltage-wise with our three-phase Y system. So between A and neutral, I'm going to erase this. Between A and neutral, this is a 120 volt winding. Between B and neutral, it's a 120 volt winding. And between C and neutral, it's a 120 volt winding. But if I put my leads between A and B, between B and C, or between C and A, that is called line voltage. So my winding voltage for some reason my pen isn't working until later. Yes, there we go. So my winding voltage is going to be 120 volts for the winding, but my line voltage is going to be 208. And we'll just wait for it. There we go. So the line voltage is 208. My current, if I put an ammeter over my winding A, I will get my line current, and whatever my winding current is will also be my line current. So in my Y system, my winding current is going to be equal to my line current. Okay. So obviously that's going to be completely different when we get into my delta system. In my delta system, if I have 120 volts on A phase winding and 120 volt B phase winding and 120 volt C phase winding, then my voltage between A and B is going to be 120. My voltage between B and C is going to be 120. And my voltage between C and A is going to be 120. So for my voltage, my E winding, write that in black anyway. My E winding equals E line in delta. And that'll write in there hopefully here any second. There we are. Shitty. But now when it comes to my current, now if I put an ammeter over my winding, a winding, let's just say, if I put my ammeter over winding A, so I winding, and I put the clamp on ammeter over my winding A, and I get, let's just say it's 10 amps. If I put it over my wire A, if I put my ammeter over that wire, now I will have my line current, I line, and my line current is what we are going to now multiply by 1.73, so that'll be 17.3 amps. So for Y, my winding voltage is what the coil, the winding, the voltage at the winding to neutral, but my line voltage is going to be A to B, B to C, C to A, but my current is going to be whatever my winding current is going to be my line current in Y. But when we get to delta, my winding voltage is going to equal my line voltage. So if it's 120 volt winding, it's 120 volts between A and B, 120 volts between B and C, 120 volts between C and A. And then when we put our ammeter on the winding, we'll have a multiple of 1.73 to get to our line current. Hopefully this didn't confuse you too terribly bad. We'll answer questions about it in class. Feel free to reach out if you have any questions.